So, what up? Today we are solving day 14 and we are of course solving this in the programming language NIM. We are learning it while we are solving these Advent of Code challenges. And today we are inside of a cave and we have a scan of the rock above us, at least that's what I think it is. So our input looks something like this. These are basically XY coordinates for where the rocks are placed, like in the cave roof, something above us. And from this input, we should construct this map, also depicted here on the drawing board. I think this is, well, yeah, it's close enough to the example. I think it will work anyways. And what happens is that sand will slowly and steadily fall through between these rocks and fall down. And our assignment is to sort of like calculate how this sand falls down, basically. And this is how it goes. So we have this, the matrix here is the sort of like the cave or the cave rock stuff thing. And then here, depicted by the red arrow, this is the place where sand starts to fall in. Sand is depicted by a plus sign, just for some reason, and the red ones are rock and the green ones are air. So for example, this corn of sand would fall down, 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 and then land here. And when it lands, we depict them by this lowercase o. So that's where the first piece of sand falls, and they occupy one tile of space here. So then we have these rules that when the sand falls down, it first checks, can it fall like straight down? If it can, it will. If it can't, it will check like the diagonal left. If it can't, it will check the diagonal right. And if it can't stay there, then it has to reach its destination. If not, and we will see what happens if not. So let's actually start to populate this a bit according to the example. I will probably wind this quickly because this might be slightly boring. Okay, I think actually we need to have one more over there, because that would also be possible, but this is kind of like the image that you get. Now I realize how actually different my drawing is from the example over there, but it doesn't matter. So what we can see here is that at some point it sort of like stops. We're not able anymore to push more sand through here. I think this is actually, I painted it a bit wrong because this sort of like stops and then it just can't go down anymore. Whereas in this case, what happens is that the sand starts to fall here to the side, and then it will fall like, for example, here, 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 and here, and then the last piece of sand that would fall would sort of like fall out of bounds of this image. So it's sort of like, as described here, it's falling into the endless void. And that's the thing that we're searching for. So we want to know how many units of sand this particular construction can take before the pieces of sand units start falling into this void. So not very complicated. This is more going to be just about parsing the input, getting everything set up correctly, not making any stupid mistakes. And yeah, that's going to be it. Let's code. So we're going to start by import secutils import strutils, and then we're going to set up a few convenience things. So we're going to have a coordinate, a sequence of coordinates like that. And that's the only thing we're gonna need. So this is how I'm going to map this. Let's split it. Is line.split, and we want to split at this character. The reason being that this way sort of we can split each coordinate. They are marked like this, which is quite nice. So now for core in splitted like that. So now we can let's do clean chord, which is do like chord dot replace, because I don't want to have this have the white space. I don't want to have that. So these are parse int like that. That should be the correct way of doing it. And now we just need to, of course, put a comma. And now we can say that, what do we have? We have our temp rock dot data dot add temp chord. So like that, and then we want to have var list of rocks. It's just a sequence of rock. And then we can do here in the outer loop, we can do list of rocks dot add temp rock, like that. So now for rock in list of rocks, echo rock, and that should give an error because we haven't implemented our special printing functions. So I'll quickly do that. And like that. So now what are we printing? For rock in list of rocks, we're printing the coordinates of like this thing here. So rock number 1 goes from this coordinate to this coordinate, from this coordinate to this one, and the latter one from these. So, all right. And I will not be using my matrix library from previous episodes because, as we saw previously, it had some problems. So I've just created a grid, which is just like an object, which has the sequence of character. Just hard coded it, and then just a known function for it to print it beautifully in the form of a matrix. But now the bigger problem here is that if we look at these sort of like the matrix coordinates where these rocks are, we can quite clearly see that, okay, these are some large numbers, and I'm not interested in having a matrix go all the way from, what's the largest here, like 503. So going from 0 to 503, like that's going to be not so pleasant to visualize. So what I'm thinking, like, let's find the minimum x and the maximum x, and then just scale those to like from 0 to the biggest. So I think, yeah. So like that. Now we've declared the minimum and maximum y and x, and then let's have a specific function for converting this. So proc convert scale. I'm gonna take in, how should do it? It's just like c, yeah, coordinate, and then just turn void. So we can say that convert scale chord. And does this, oh yeah, exactly. Min x and min y. So that works. But now after we've done this, I'm actually gonna set the min y to 0, because we still, even though if like this is where we draw all the rocks, we still want to have the rows all the way to 0, so that we're able to insert the falling sand. All right, so now we have a grid. Just instantiating that grid, we are converting our coordinates from 0 to something logical, and then I now have the draw rock function. So let's just go through this quickly, nothing special going on here. So we take of all these points in a rock, we take them always pairwise. So for example, these two coordinates first, and then we have to check sort of when we draw, should we draw like along the x or y axis. So if x are equal, then we're drawing on the y-axis, and then we're creating this range. Have to check which one is like the bigger and smaller number. Yeah, small hacks like this, and yeah, nothing special, to be honest. It turns out actually quite nicely, I'd say. So here we see we draw the first sort of line of rocks, which goes from yeah, basically this number to this, or these are the same, but from like 4 to 6. And now, as you can see, we've scaled this 498 to be, that's maybe like somewhere 5 or something like that. And then there's another line of rocks to that same rock formation. Then there's a new rock formation coming up there, another line to it, and then the last line. And this is our final analysis of how the rocks look like, and it's same as in the example. Looks really nice. So if g.data at current x, current y, and now this should actually be +1 because we're going down one row. If that equals the air particle, that means that we can move there. And now let's just copy paste this stuff here like that. A lot of indentation. So what can we then say? Then we can say that in the position from the current position 1 down, then that should equal to the plus sign now. And then this one, let's set the previous, or where we are actually now, let's set that again back to the air sign. And now we have to do this whole thing for like checking all of these stuff. I'm not good at speaking always at the same time. So yeah, okay. So again, we have to do all these checks. So now if we can go down, so what if we can't go down? We have to check left and then right and so on. So let's do that. So what happens else? So if none of these conditions are met, then that means that we have arrived at our final destination, and we can set the current y and current x to O, and then we can say has landed equals true, because we have landed. Let's see what happens. Okay, so yeah, we're drawing that one, and yeah, now we see, okay, no, that doesn't work. Oh yeah, and obviously why that doesn't work is because we are not incrementing the current x in this case, because yeah, if this is the case, we also should we should move. So yeah, here we're gonna increment, in all of these cases we're gonna increment the x, and here's I'm gonna also increment the current y. Is there like a deck? Yeah, okay, current y. Let's see if that works. Okay. Hey, come on, look. It goes down. It turns to a 0 or O. This goes down. It goes left. It finds its place. Okay, it settles. This goes down. It should now go to the right. It does. It finds its place. All right. Hey, this actually looks like our simulation works. So, okay, and now we went out of range in the loop. So let's do this again. We're drawing, let's not do that. Okay, now we're simulating the sand falling. As you can see, this beautiful animation in black and white goes. And now we get into an out of bounds index, which is basically, it's not what we want, but that's basically the answer that we want. Because the question is how many units of sand can come to the rest before the sand starts flowing into the abyss below. And basically it starts flowing into the abyss below when we get an index out of range error. So basically now instead of like getting an error, let's just catch that error in some fancy manner and let's just like print it to the standard output. And that should be our answer. Okay. So now, instead of having hard-coded at the start, I actually did this intelligently. So the sand always falls down at the position 500. It says somewhere here, yeah, 500. So yeah, we just take the minimum minus 500 and we get the corrected one. And what else do we do? Yeah, while true, just increment that, and then we pass in the rounds here, and then yeah, this is maybe not like yeah. I don't know if this is the best way, but it's a way. So we can just like try to sort of like access that place in the grid. And try it. We're not going to do anything with that value, so we have to discard it. And then if this throws an error, then we just quit the program, and before that we print the round that we're currently at. So that's like a way of checking that are we out of bounds. Like that. Boom, and it's running and running. So yeah, let's see if we are regretting this or not. That's okay, we are regretting this. We are officially regretting this. So let's not echo G it there, but we can do it here at the end, echo G. So we still get the thing, and it's called grid. Okay. Oh yeah, of course it doesn't print it because we exit the program. Okay. That's a bit of a shame actually, but hey, you at least got a glimpse of it. And yes, it's correct. It is correct. Let's move on. So on to part B. So now, instead of the pieces of sand falling into this void of oblivion, we actually realize that we are standing on a floor, and these pieces of sand are actually falling onto that floor that we're standing on once they sort of like flow over this formation of rocks. Okay, so the floor is sort of like depicted here where we're standing, and now what instead happens of like them falling just like into oblivion, we start gathering a stack like this. So the sort of pieces of sand, of course, don't like start flowing all the way to ground. This is not like liquid water. It still keeps some form. And now the question is, how many units of sand come to rest until we actually reach the place sort of like like the place doesn't fit any more sand simply. So what we need to do is, first of all, we should here where we are, we have our list of rocks. So we should manually append to this list of rocks just like a starting and ending coordinate for our floor. And it's from -infinity to +infinity, but let's just be pragmatic about this and choose a very, very sort of like a number from like the very beginning to something like maybe like from 0 to something very large. I think, at least I hope that will be enough. I hope. And then here, so here we are detecting when we want to stop the loop by doing this try except, because we get an out of bounds error. So now we can't rely on this because we won't get an out of bounds error. We actually have to implement some logic to check sort of like, okay, we're trying to insert a piece of sand at the very beginning place, and then that will be our cue sort of to say that now we're done. Let's calculate how many rounds we've done. So pretty straightforward. I think the most complicated thing is going to be like doing this minus infinity to infinity and simply just checking like converting all this stuff, because now we converted the scale to something else and now we want to convert it back and it's easy to mess up. So hopefully. So let's start by creating a floor, which is a rock, and we have a data, which is a sequence of coordinates, 1 coordinate, 2 coordinates, and they both have x and y values. And now let's just echo the grid. All right, and that doesn't work. So yeah, of course I have to put that there. And yes, now we have the floor. And now what I would like to do is I would like to sort of like continue it to the right. So let me also create like, let me think. I want to have a variable called, let's scale right. Let's set it to 10. And where should I put these? If I put it at there, scale to the right, and then I should put here also plus scale to the right. So scaling to the right should be quite easy because we're just like adding more stuff here, and that's quite straightforward. But now scaling to the left is a bit more difficult because it means like every item here has to be sort of like pushed more to the right. So we can't just like, because now we started this thing like the most left column is at index 0, so we can't just make like negative columns. We actually have to push everything more to the right, which means that we have to be very careful not to mess the already working indices of these. But let me think. So I'm thinking, actually we could have probably done this also with scale right. But hey, that works, so let's not mess it up. Scale left 10. So what I'm thinking now is that where's the min x? What if we just do like that? And it works. Like a charm. Like a charm. Maybe we should do that after we increment, or I don't know if it matters. So, okay, that was quick as... let's do one more. Discard, read, line, standard in. So we get, I mean, come on, it's Christmas after all. So now let's, okay, now you see it filling, and done. Okay, so that was for the little animation that we had, and this seems to be working just fine. So now let's take away those, because with the big thing we don't want to do that. And then let's change these wherever I'm defining this, of course. So let's make this something like scale left 1000 and scale right 1000 as well. And then let's just pray that that works. I don't think I even have a proper way of checking if that doesn't work. Input.txt. Now pray to all the gods that there exist. Okay, that finished. So yeah, we of course expect this to take more rounds than the previous one. Let's just check. Okay, so this is, yeah, okay, this is, yeah, significantly more. But is it enough? Oh, and it's too low. It's too low. It might have to do with the... Let's see, are we getting a... One thing we can do here is we can echo out of bounds. And let's put this also to all these... echo out of bounds before we quit. And then we can see sort of like, is this... Yeah, it's due to the out of bounds thing. Interesting, interesting. So 1,000 wasn't enough. Okay, so I think I have an extreme newbie bug here. So the scale right is not never changed to wait, scale left, scale right. Yeah, no, this should be the scale right. So I think that actually was the problem. Now we can put back our. Let's start with, I don't know. Let's start with 1,000. That's, I don't know, might seem reasonable. So yeah, as you can see here, I caught the bug by visualizing. I think, yeah, visualizing usually helps. So you can see here it stops. And this is what the whole thing looks like. We didn't see it previously, but it's quite a big thing. Beautiful, beautiful. So we are giving this another shot. Yeah, let's do that. Let's just run it, see what happens. Okay, and now we get, yeah, now it didn't get to out of bounds, so we are more confident, and it's still too low. It's too low. So finally, 93, that is exactly what it should be. No -1s missing or anything that goes on. So we just get that incremented by 1, and finally, yes! Done and dealt with. So, this was Advent of Code Challenge 14. Today we ditched our own matrix library, and those people who are depending on this library, we will no longer be maintaining it. I'm sorry for all you folks out there your projects are dependent on this, but that's the way it is sometimes with open source projects. No, yeah, maybe this is a better way of just like quickly hacking together like two-dimensional structure where you need dynamic sizing and stuff like that. If, of course, like there are good array tensor libraries in NIM, in real projects, use those. Maybe actually I should try in one of the videos instead of like building my own every time from scratch. It could be actually quite nice and a nice like education opportunity to do that. Otherwise, not anything specific. System quit was the first time we saw that. Otherwise, yeah, pretty standard stuff. We are happy with this, and see you in the next one.